Welcome to the Mississippi River activity. Did you know that the Mississippi River touches 10 of the United States? It is the second longest river in the U.S. with a length of 2,340 miles from its start in Minnesota to the mouth in the Gulf of Mexico. We all know that water takes the path of least resistance, which usually means it flows downhill from a high elevation to a low elevation. This means that the water flows over a slope. Since the Mississippi River is so long, we cannot assume that it has the same slope for the whole distance of the river. Rather, that the river flows fast in some parts and slow in others. It will be your job today to discover the fastest and slowest parts of the Mississippi River using your knowledge of slope and the information provided on page 1.5. So here's the information. Notice that we have the cities along the Mississippi, and we have their elevations of each one of these cities and the distance between the cities. So the first thing we're going to do is we're going to use that data and calculate the slope between each pair of the cities. And we can do this on page 1.5. So here's how we're going to do it. We're going to take the slope, we're going to make a fraction, the rise or run, get the change in elevation between the two cities and the miles between the cities. Now, note that since elevation is always decreasing, in this example, all the slopes to be negative because the water is flowing down here. So let's go to 1.5. I'm going to put my cursor right here, and again, this is all on the calculator. So I'm going to press Control, divide, and let's look at Twin Cities and Lacrosse. So let's get the change in elevation, 834 minus 651. And I'm going to put in the denominator the distance between those two cities, Twin Cities and Lacrosse, is 144 miles. And if I press enter, I get 61 over 48. And remember, we're going to make that negative. Okay, let's do it for the next city, next two cities. Now we're going from Lacrosse to Dubuque. So I'm going to go Control, divide, and let's see, Lacrosse, let's find this elevation. Lacrosse is at 651, Dubuque is at 620. So I need 651 minus 620. And the difference between those two cities is 129 according to the chart. And if I need to make sure that's in my denominator. So 129. And if I press enter, I get 31 over 129. So I'm going to do the same for everything else in that chart. So as you see, I have calculated the slopes of all of the 9 cities along the Mississippi River. And remember, these are all going to be negative. So let me go back to page 1.6. We've done step 1. Now we're going to enter the elevations of the city in order in the elevation column in the spreadsheet it says page 1.8, but it's actually page 1.7. So I'm going to go to the elevation column right here, and I'm going to put in these elevations. Right here where it says elevation above sea level, I'm going to put these elevations in, starting with 834. Okay. Now, as you can see, I have, let me go back to the top. All right, here's the elevation column, and I've entered in all of the elevations of all the cities there. So the next thing I'm going to do is I'm going to page 1.6. We've done step 2. Let's go to step 3. Enter the miles between the cities in order in the miles column in the spreadsheet. Again, this is 1.7. I'm going to change that to 1.7 so that it matches. But you get the idea. So let's go back to our spreadsheet, and I'm going to just cursor over to the miles column. And if I look at my miles in order, actually, if I go to back to 1 point, look at that. There, I'm going to start off with a 0 because the miles between Twin Cities and Twin Cities, I mean, it's just one city, so we're going to start off with 0 there. So I'm going to put a 0 there. And then the next thing I'm going to put in is a 144 according to that sheet. And let me go, the next thing I'm going to put is 129. You see where I'm reading it from? 129. All right. And let's go ahead and put the rest of those in. Okay. And I'm putting the last one in. This is miles between Vicksburg and New Orleans. So that's the last one. And I'm making sure I'll go down so that that's done. All right. So let's double check, make sure. Notice that I got everything. It's all lined up. Okay, good. Looking good. All right. Go back to page 1.5. 1.5. So the next thing we're going, oh sorry, not 1.5, 1.6. We've done step 3. Now we're going to calculate the cumulative miles and the C miles. The C stands for cumulative, by placing your cursor in the formula cell, column A, then press menu 371 var, then select miles and press enter. So let's do that. So I'm going to the C miles column here. So I'm going to go here and I'm going to scroll up. Okay, right here. Oops. All right, that's okay. To get back into the document, I'm just going to press 4 for current. Okay, so let's go ahead and put in the formula cell. Remember, we're supposed to be in the formula cell of column A, formula cell, and then we're going to press menu 371. Okay, 371. All right, now I'm going to press the variable, then I'm going to go down to miles, and then press enter, and then I'll press enter again. Notice that it found all the cumulative miles there in red. Notice that it recalculated the slopes for us, and these should match the ones that we had on 1.5. All right, the only difference is that these are all negative because they're all decreasing elevations. So that means we're doing pretty good. All right, so if I go to 1.6, and now I'm going to go to step 5. Note that a scatter plot has been automatically generated on page 1.6. Connect the points using a piecewise defined functions and determine where the Mississippi River is fastest and slowest according to the steepness or the slope of the line set. Go here. So what we're about now is we're going to use piecewise functions to keep the graph, to make the map. That's what we're getting ready to do. So I will demonstrate. So we're going to use the point slope formula to define a piecewise function from one point to another. This is the formula we're going to use. F of x equals to m times x minus x1 plus y1, where x1, y1 is the coordinates of a city. So here's an example. For example, this is the first one we're going to do. For the segment from Twin Cities to Lacrosse, the slope is a negative 61 over 48. The point where the city is, Lacrosse is 144, 651. Notice that 144 is the miles that we've traveled down the Mississippi, while 651 is the elevation. So the equation is y equals the slope times x minus the cumulative miles equals to elevation. All right, and we're going to put a piecewise constraint. That should be the word, constraint, actually not constant. Let me go ahead and fix that. 0, x is going between 0 to 144. So let's put that in. So I'm going to go here. First of all, I'm going to do this actually one at a time. So I'm going to put Twin Cities. Let's grab Twin Cities and let's move it into place. And let's move the next city, which is Lacrosse, and let's move it into place. I'll get Helene in a minute. All right, that's 20 cities, that's Lacrosse. Okay, let's put in our equation. I'm going to hit tab, and then I'm going to type the word piecewise, Piecewise. All right, piecewise, I'm going to put a parentheses. I'm going to put in the slope. Okay, the slope was, I'm going to do control, divide, negative 61 over 48. Put in the slope of the line between those, the river between those two cities. All right, then I'll put another parentheses, x minus the cumulative miles is 144. And then I'm going to come out of the cumulative miles and I'm going to put a plus the elevation, which I believe is 651. 651. And finally, I'm going to put in the constraint. So I'm going to put in a comma. And I want x, starting at 0.0, x. I really just need a less than will be fine. But yeah, we'll do this. We'll just use a less than or less than equal to. All right. X, either one of them will be fine actually. All right. X is between 0 and 144. And when we do that, we should get, and you see that? Let me move this out of the way. All right, when we do that, we get a line between those two. We get a segment between those. So I'm going to do one more and then we'll complete it. Okay, so let me hide this one. So, well, actually, yeah, I'm just going to use it as a model for the next one. So let's say I'm going to do the next city. The next city is, let's see if I can go back. The next city is going to be right here, is from Lacrosse to Dubuque. Lacrosse to Dubuque. So I'm going to drag Dubuque in here, right there. All right, let's get that slope. Okay, the slope there is negative 31 over 129. So let's do that. Let's hit tab. And I'm going to first type the word piecewise. And let's see, let's put in our slope. Let's, we want, first of all, let me give you a fraction here. Let me give me a negative. And let's put control, divide. And let's see, our fraction was, let's see, let me get my fraction here. Fraction was, I believe it was negative 31 over 129. So I needed 31. 129. And we're going to put in parentheses x minus, all right, what was the cumulative miles? Cumulative miles, let's see, cumulative miles, then you get that from the spreadsheet. Probably a good idea to write this down so that you don't have to switch pages like I'm doing. 273. That's how many miles we've traveled down the Mississippi so far. And we're going to end up with the elevation of 620. So plus 620. And then I'm going to put a comma. And this time we've already gone 144 miles. So we're going from 144, control, all right, let's use, I'm always going to use that. X is between 144 and 273. So I'm hoping you see the pattern that I'm using here. 273. And then when I press enter, now I get another segment. The nice thing about doing this way is that it colors the segments for you. Okay. Now these are going to really pile up. So what I'm going to do with these is I'm going to actually just let's see. The way that I can clear this is I don't want to turn the graph off, but what I do want to do is I want to hide these. So what I can do is let me hit escape. Let's click here. Let's hit control, menu, and 2 to hide. And that's going to get rid of this label. So let's do the same thing here. Here, control, menu, 2. Don't delete it, hide it, because you don't want to do it again. So I'll hit hide, and that way I can just go on to the next one. And remember, when you hit tab, if you hit, if I go back and I hit tab and put it in the next, if I want to see the ones that I did before, they're still up there. They're still there, okay? So I'm on F3 now. Now here's a technique I also did to kind of speed things up, is I actually went up to one of my earlier ones and I did a copy paste with control and let's see how I did this. I did a copy paste, I put my cursor right here and I hit control and hold down shift and I did a copy and paste. I can show you how to do that if you want to, but I'm doing a traditional way right now. So I did a copy, then when I go to F9 I just paste that, and then I just change all the numbers to what they should be. So that's something that you can also do as well. So let me go ahead and put this final one in. There should be a 7 there. All right, and this is from C Miles. See, we're at the end of the Mississippi here. All right, now this, instead of a plus, this is going to be a -4 because we're adding a -4. So I'm going to go -4 there. And we're in the last bit of the trip, so this is going to be 1161 and I'm going to put 1322. Yeah, that's right, 322. When I click that, I should have that. All right, and so that's my final function there, my final piecewise. I'm going to hide it at this point. All right, I don't really need this label either, so I'm going to hide it as well. Yeah, I think I did it. Okay. All right, so then, oh, I didn't do that. I wanted to hide it. Let me hide it. Control, menu 2. Safe to do it that way. All right, let's drag the rest of these cities in place. Double check. check here. Yeah, Helena, Vicksburg. Okay, yeah. So let's just say Helena next, Vicksburg next, and then New Orleans. Okay, all right. So that's what it was looking like right now. It would be your job today to discover the fastest and slowest parts of the Mississippi River by using your knowledge of slope and the information provided. So let's look at these slopes and determine which of these slopes here is the steepest or the largest. So if I look at the slopes here, and there's plenty of places where you can look at these fractions here and determine which one is the biggest. Now, you might also notice that in column E, it also made a decimal version. It also converted the fractions to decimals. So what I want you to do is determine which of these fractions or decimals is the largest, and then which is one of the smallest. So wherever you find the largest fraction, let's say you thought it was this one. So if this one is the largest decimal, the most negative decimal, that would be Lacrosse. Okay, and so you will put here the Mississippi is fastest between whatever those two cities are. Okay. All right, and then find out which decimal is the smallest, and then that's going to tell you where the Mississippi is slowest between. And that pretty much concludes the project right there. So, but you have to. This is yeah. So I'm gonna have you guys to turn this in, and then I'm gonna also collect it as well. All right, because it's going to collect one way. It's going to collect one way and we can turn in so I can get all your work. And that's the project.